This video will be on how to multiply surds. So before we get started, there's just a few things to understand, and I'm going to go through them now. If we took two numbers, like if we have 6 and we square it, okay, we all know that that's 36. But if we write 6 as, say, 2 times 3, and we square it, well, I know this feels like it's going around the world, but what I'm trying to show you is instead of just multiplying and going from 6 squared to 36, we could also square them individually. So remember, whatever's in the brackets, that means all of this is being raised to the power of 2. So that means I could square both of them, squared, and that would give me 4, because 2 squared is 4, and 3 squared is 9, and I still get the same answer of 36. Okay? Why am I telling you this? Why am I reminding you that everything in the brackets gets raised to that number on the outside? Well, that's because over here, I'm going to square root two numbers. And the square root is the same, it's the opposite operation of squaring, but the idea is the same, which is if you're going to square root c times d, that would be exactly the same as square rooting c and square rooting d. Just like that's the same as squaring 2 and squaring 3, we would use this operation applies to both the c and the d. The other thing I want you to know is that if you have a regular number on the outside of a surd, for example, 2 multiplied by root 5, the way we write that is 2 root 5. Okay? Just like in algebra, if we wanted to write 2 times y, we would write that as y. So c times d is c root d. Okay, so we can't put that c underneath the square root sign because it doesn't have a root over itself. And the last important rule I want you to understand is if you have a surd multiplied by another surd, which it might change that, what we're going to do is we're going to write it as the square root of x. If you multiply anything by itself, that's the same as squaring it. And when you square something, and you square root it, those are two inverse operations and they cancel each other out. So what we would be left with is just x. So how will that be useful? Well, it's important for you to know something like root 2 times root 2, we can go straight to 2. I'd prefer you not to say root 4 and then 2. I'd prefer you just to go straight to 2. So these concepts in the box are what we're going to be applying when we do our questions. So let's have a look. This first question will be using that idea that if we have root c times root d, okay, if I separate them, if I go back, I can keep them separate or I can put them together as one big surd. So I'm actually going the other way. So here they are separate. If I want them to put them together, I would combine them as one big surd, and that would give me root 35. So you can actually combine the two numbers, multiply these together, and if you know what that is, you can just write it as root 27. What you need to make sure though when you've finished is, does your answer reduce some more? Here my answer doesn't. Here my answer does, and you are expected to always reduce your surd fully. So the square number that goes into 27 is 9. 9 3s are 27, so I'm going to change this to 3 root 3. You must go fully down to the final answer. Okay. Sometimes you can reduce the surd first. I could have actually made that just 3 straight away, just like I'm about to do now. I could change root 8 into root 4 times root 2, and then that would become 2 root 2, and then I can combine my surds. Root 7 times root 2 is root 14, so I'll be left with 2 root 14. So numbers that do not have a square root sign over them, they remain out the front, just like it has here. Same thing happens here. We've got a couple of numbers out the front of the surd sign. Those are just regular numbers. We'll multiply them in the usual way. 4 3s are 12, and root 2 times root 7 is root 14. And there are no square numbers that go into 14, so I'm done. Root 3 times 9, well, that gives me 27. And here we're going to be applying this last rule from the previous slide where we have a surd times the exact same surd and how we end up with the number under the square root sign. So if I'm multiplying root 5 by root 5, that will become 5. So really we're going to get 27 times 5. And I can do this by doing 20 times 5, which is 100, and 7 times 5, which is 35. So I'll get 135. Once again, numbers in front of the square root sign I will multiply. That gives me 20. Surds, so the numbers under the square root sign, I can also multiply that and that. That gives me root 44. And hopefully you're thinking about, does it reduce? Well, yes, I know that under that square root sign, I can put that square number 4. 4 times what gives me 44? 4 11ths. So the square number must always come first. That's why I put it over here. That's going to reduce to 20 times 2. There's imaginary time signs in there. Times root 11. So I'll get 40 from the 20 times 2, 40 root 11. Just a few more to cover that last concept. If you have a surd squared, remember these inverse operations will cancel each other out. So we'll be left with 7. Here, my inverse operations will cancel each other out. So I'll be left with 11. Here, once again, my inverse operations will cancel each other out. So I'll be left with 3/4. Oops, let me change my pen. Now here, when I square, I actually have to square everything. Everything inside the brackets must be squared. So 3 squared, well, that's 9. And root 2 squared, well, that's 2. Remembering that when we square a surd, we just left with the number underneath. So that gives me 18. If I want to cube a surd, well, I need to cube this number and I need to cube that number. So 2 cubed, that's 8. 2 cubed, don't forget 2 cubed is 2 times 2 times 2. And then we're going to do the same with the root 5. We're going to do root 5 times root 5 times root 5. Well, don't forget that root 5 times root 5 is 5, and then 5 times root 5 will give me 5 root 5. Then I can go and combine my 8 5s, which gives me 40 root 5. Now we're finishing off with a power of 4. Okay? So we're going to raise the 10 and the root 3 to the power of 4. So we're going to do 10 times 10 times 10 times 10. Can I put it in? And that will give me 1 with 1, 2, 3, 4 zeros. Then I need to do the same with root 3, except for root 3 is a little easier. Root 3 times root 3, that gives me 3. And then if I do it again 2 more times, that'll give me my 4. These give me 3, and 3 3s are 9. So in the end, I get 10,000 times 9, which is 90,000. Hopefully I didn't go too fast. I recommend pausing the video, thinking about things, rewinding, and watching it more than once if it is tricky. Okay, but from here, you should be able to complete the multiplication section of surds in our notes.